This video is about leveling. Leveling is the idea of surveying the land to see basically how steep different inclines are, so we can make contour maps like that big map of the school. Okay, if you have a look back at the map of the school that we had, you'll notice there's all these contour lines showing how high the different points are. So in our classroom, somewhere over here, I don't know, around here somewhere, we're about 25 meters above sea level. If we go down to the oval, it's about 18 meters above sea level. So the way all of these things are calculated is by using some surveying or leveling techniques. Okay, for example, making this fence in the backyard, need to make sure that we cut off all of these in a level way so that our fence doesn't look silly. The few leveling tools that we can use. Okay, there's a spirit level. I'll bring in one of these tomorrow to have a play with. Okay, if I was trying to make my fence level, I would put a straight edge, like a piece of timber, across the two posts and put a spirit level on top of it, and I would make sure that the bubble is in the middle of those two lines. Hopefully we've played with one of these before. Also got a line level. I think I've got one of these. I'll bring one in tomorrow to play with. Here we can also use a water level. So we put water in a tube and just see where the water level goes up to. Might be able to find one of those to play with. And if we have any luck, we might be able to use some of these more sophisticated tools. Okay, this will be us playing outside if we're well behaved. All right, so what we can do with levels. So this one we'll do in class as an activity tomorrow or whenever the lesson is. We can use this leveling idea to calculate angles of elevation between 2 points. Okay. Essentially, we have two staffs, two rulers that go from like 0 to 3 meters, or however long they are. I think the one we have at school is about 5 meters, and we can use it to calculate the rise. So I want to know the difference between these 2 points, and difference in heights, and I also want to know, on average, what is the angle of elevation there. Okay, so first of all, to calculate the rise, okay, I'll take the difference between these two staff measurements. Okay, so the difference between those two is 1.42. Okay, assuming this is meters, yep, 1.24 meters difference. If it's the other way around, okay, if I'm looking at a fall, okay, downwards, okay, I'll just write fall equals and do the same subtraction. Okay, so part A, the fall is 1.42 meters. Part B, the angle of elevation. So I've got a triangle from A to B where I know I go up 1.42 meters and I've measured this distance as 24 meters. I want to find this unknown angle here. Since we're all good students at the start of this unit, we should be able to calculate the angle without too many issues. Okay, I'll identify that this is the opposite side, this is the hypotenuse, so I'm going to be using sine. Okay, I'll write the rule, sine theta equals opposite over hypotenuse. I'm trying to find that unknown angle. I know the opposite side is 1.42. The hypotenuse is 24. To get the angle, I need to inverse sine this guy. Okay, if you're struggling with that, go back to the start of the unit and have a look at the tips there. Get out my graphics calculator. Hopefully no one's been mucking around with it. So I'll check in Shift menu, check that my angle is in degrees, and then I can find inverse sine of 1.42 divided by 24. I don't know where my 24 went underneath there. 3.39 degrees. Okay, which is saying that to walk up from A to B, we'd have to walk up at an angle on average of 3.9 degrees. Okay, same thing, if I was talking about the angle of depression, it'd be the same, 3.39 degrees. I'd have to walk down to get to A. Okay, so the fall, or correction, the rise between A and B, okay, we're walking upwards, and I'd write here angle of elevation is 3.39 degrees. Okay, this final problem uses the idea of ratios. Okay, the fall is necessary for drainage so that water doesn't stand or puddle on the surface, for example a driveway. So even if your driveway at home looks flat, it probably has a small slope to it so that water doesn't just sit there and flood and ruin your concrete. So look at this scenario, the fall required for a gutter to drain properly is 1:500. So I've got this gutter where this ratio means that every 500 units I go across, I go down 1. So it's saying how much fall is required for a 16.4 meter ladder. So I've got 16.4 meters, correction, 16.4 meter gutter. I don't know what that fall required will be. So I've got the idea of similar triangles. Okay. Just like in that previous unit about indirect measurement of distance, I'm trying to find x. I'll divide it by this corresponding side, and it'll be the same as where x was on this diagram, divided by the corresponding side. Okay, to get x by itself, I'll multiply by 16.4. Okay, end up with 0.0328 meters, okay, or 3.28 centimeters as the fall. Okay, alternatively, if you don't like that idea of similar triangles, I'll put the alternative over here. We can just say the fall will be 1/500. So change this ratio into a fraction and multiply it by 16.4, which is the horizontal distance. And we'll get our 0.0328 meters, or 3.28 centimeters. Okay, so we'll do a little bit of activity first in class with rulers, then we'll have a go at these questions, and then if we got time, we'll go play with some real surveying equipment.